Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This is a third and final video on hyperbolas and conic sections. So in this video, all we're going to do is build equations for hyperbolas, given some information, and then we'll go ahead and do an application as well. Very typical of all conic sections, you're given a few pieces of information. You have to use the standard form for your conic that's in question. In this case, is a hyperbola. And then you use that information to kind of pull it all together to create that standard form of your equation. So let's see. And often you're going to want to graph as well, just to visualize. And it is important to note that sometimes in mathematics, very often in fact, you don't have to do everything in the order they ask you. Sometimes it's more important to go backwards. For example, I would prefer to graph this first and then find the equation because it helps me find the equation by first graphing. So that's what I'm going to do here. The very first thing I do, draw out the axes, and notice that the numbers involved here get somewhat large, right? 3, 5, and then that's the center. And then the vertex we have is at 3, 11, which means that my y-axis has to have values that are scaled appropriately so I can get to that value of 11. So that's what I'm going to do. I'm going to scale my axes similarly, that's hard for me to say, so that I can reach those values. So let's see, let's go ahead and go by steps of, let me see. I'll go by steps of 2 so that each of these little hash marks on here will be a step size of 2. Just will make my life a little bit easier. So doing this, I'll just go ahead and mark these on there. It's 2, 4, 6, 8, 10, and 12. So 11 is halfway in between. That's all I really need. And then I'm also going to do the same thing horizontally. So I'll put a bunch of little dots on here for the horizontal scale of 2, 4, 6, 8. I don't need to go that far with that side because our x value is 3. So let's go ahead and plot 3, 5. So that would be x equals 3, which is roughly right between the 2 and the 4. Not just roughly, it's exactly between the 2 and the 4. And then up 5 units. So that's 2, 4, 5, just right about here. 2, 4, and 5, right about there. So that's one of our vertices. Or sorry, that's our center. I mean the vertex. So that's our center at 3, 5. 3, 5. And now let's see what else we have. We have a vertex at 3, 11. So I'll just line right back up there. There we go. 3, 5. 2, 4, 6, 8, 10, 12. So 11 is probably right about here. That will be, what is that? 3, 11 will be a vertex. So mark that on there, 3, 11. Now, if that's the reason why I like to plot like this first is because if that's a vertex, then that many units below will be another vertex. So 3, 5 is a center, 6 units up is a vertex. So 6 units below will be another vertex. So let me go ahead and just go 6 units below there. 1, 2, 4, and 6. So 6 units below is right about there. Just double check. Yep. So that'd be 3, -1. Marking that on there. 3, -1. That's the other vertex. And now, what else do we have? We have a focus at 3, 5 plus 2 root 10. That, just to get it accurate on there, I'm going to go ahead and grab a calculator and find out what 5 plus 2 times the square root of 10 is, so that at least I can figure out roughly what the value for the, or y value for the vertex is. And it's roughly 11.3. So 3, 11.3. And let me go over these up again. It's not going to be very close to that. So 11.3. I do my foci. Is that what a vertex or foci is? A focus. So I'll do a focus just barely above. That's 3,5 plus 2 root 10. So really very, very close to our vertex. And the same thing down below. In fact, I'll just eyeball this one. I'll just say that this is right here in red. 3,5. Oops. Actually, now that I'm thinking about that, so it's 3,5 minus 2 root 10, because we were at 5 plus 2 root 10. We're going to be at 3,5 minus 2 root 10. 3,5 minus 2 root 10. All that stuff is out of the way, right? Now we've got that done, basically. Now we need to go ahead and figure out the rest of the details. Let's go ahead and do this. Finding the equation. So we know that it's a vertical major axis. So it's going to be y minus the y value for the center squared over a v sub y squared minus the quantity x minus the x value for the vertex, again squared, over v sub x being squared. And that should equal 1. Now remember, v sub y is the distance to the vertex. So v sub y is that distance to that vertex. V sub y is 6. So if v sub y is 6, then our equation is now y minus 5 squared over 36 minus x minus 3 quantity squared over v sub x being squared. That's equal to 1. Then they give us a focus. And the focus is always c units away from the center. Well, our center is at 3,5, and our focus is at 3,5 plus this. So this must be c. C is equal to 2 root 10. Now remember, c squared should be v sub x squared plus v sub y squared. So if you square c, you'll get 4 times 10, or 40, is equal to v sub x squared plus v sub y squared, which we know is 36. Subtract 36 from both sides, and you'll get v sub x squared is 4. So now we have our full equation, actually. We're pretty much done with that. I will go ahead and write this in. And the other thing you'll need here are the asymptotes for graphing. And remember, the asymptotes start at the center here, 3,5, and then you have a rise over run. So the delta y over delta x for our rise over run is actually going to be v sub y over v sub x. V sub y being 2. Oops, nope. V sub y being 6. And v sub x being 2. So 3 is our slope, plus or minus 3 technically. So I'm going to go ahead and start at 3,5 and rise 3 and run 1. Rise, again, that's 3 over 1. So rise 3 and run 1. So again, each of these pips is going to be a distance of 2. So a rise of 3, I'm just going to lightly mark that in there, is roughly around here. That's a rise of 3. And a run of 1, again, each of these pips is 2. So a run of 1 is going to be approximately here. So that will be the point that'll connect to this center right there. I'll zoom out so I can get a nice clean long line here. And then I'll do the same thing in the negative direction. Rise 3 and run backwards 1. So backwards 1 from there would be something like, oops, something like this maybe. A little bit too far. All right, connect those up. And sorry, I'm just trying to get this accurate. There we go. And I'll go ahead and draw that line connecting those two. There you go. And I'll turn off my ruler. I don't need it anymore. And we can now start the vertices and graph. See, this will be a very kind of narrow hyperbola. Much easier to graph a narrow hyperbola, by the way. It'll never actually touch the asymptote. It'll get infinitely close to it, but it'll never actually touch it. And in the other direction as well. Hard for me to draw in this direction, honestly. There you go. Something like that. And downstairs we have the same thing. So something like this. Do that. And there you go. Like that. Really trying to be somewhat careful. I want to showcase good graphing skills here. Hard to do. And there we have it. That's our equation of our parabolas off to the left, and there's our graph. And I meant the equation for our hyperbola is off to the left, and there's our graph. Now, one of the most common uses for hyperbolas is in hyperboloids for cooling towers for nuclear reactors. Now, this tower right here stands 179.6 meters tall. The diameter of the top is 72 meters. At their closest, the sides of the towers are 60 meters apart. That's what you have there. And then you can see from the smallest, the narrowest part to that top of the tower there is 79.6 meters. And we're asked to find the equation of the hyperbola that models the side of the cooling tower. The easiest way to do this actually is to just center your hyperbola at the origin. Always recommend doing that. So I'm just going to draw in a y and an x-axis here. There's the y-axis. Here's the x-axis. It just makes it a lot easier to do your mathematics. And we happen to know that the equation of a hyperbola, I keep saying parabola, but a hyperbola is of the form if the major axis is the horizontal axis, then we know it has this form: x squared over v sub x being squared minus y squared over v sub y being squared is equal to 1. And we know the distance from the center to each vertex here is actually 30 meters. So v sub x is equal to 30, not approximately, but exactly. So that's okay. So we're almost completely done with finding an equation for this tower. 30 squared is 900 minus y squared over v sub y being squared is equal to 1. Now in this case, you can't find the focus just from our picture, and you cannot really find anything else directly from the picture. However, you do know a point on the curve. This point right here has an x value of half of 72, which is 36. So the x value here is 36. The y value is this height right here, 79.6. And the reason why I'm saying that, making a big kind of statement about it, is because if that point lies on the curve, then that point should satisfy this equation. In other words, if I plug in 36 for x and I plug in 79.6 for y, this should be a true statement. So 36 squared over 900 minus 79.6 being squared over v sub y squared should equal 1. This is going to be somewhat nice, I guess, if you go ahead and move this term right here to the right hand side. You will get 36 squared over 900 minus 1. It's equal to 79.6 squared over v sub y being squared. Because I know where I'm going to go here, I'm just going to go ahead and combine these two numbers here. So you have 36 squared minus 900 over 900, so minus 900, all over 900. Notice I haven't actually computed that 36 squared. And now what I'm going to do is take the reciprocal of both sides. So I have 900 over 36 squared minus 900 is equal to v sub y squared over 79.6 squared. And then I'm going to multiply both sides by 79.6 squared. So I get 900 times 79.6 squared all over 36 squared minus 900 is equal to v sub y squared. And of course you could take the square root of both sides, but actually I don't need to. They just asked us for the equation of not what v sub y is, but just the equation. So I'll go ahead and leave it like that. I suppose I could grab a calculator and compute this out. That's very roughly 14,400. It's not exactly, but it's roughly that. And so I'll go ahead and say that the equation is approximately, let's see, x squared over 900 minus y squared over 14,400 is equal to 1. Now, let's suppose that they didn't want me to center this at the origin. Instead, they wanted the ground to be centered, or the ground to be here. So in other words, the center is up in the air. Specifically, it's up 100 meters. If that's the case, then I would just change my equation to be this: x squared over 900 minus y minus 100 being squared over 14,400 is equal to 1. That's just lifting the whole thing up 100 units. Still, everything else is the same. So just depends on how you want to build this. That's probably the way I would leave this answer. So there you have it. Really good model for hyperbolics.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.